All right, let us do some numerical exercises. So here you have a graph, and this is a very simple graph. This is the ST graph. S here represents the position. Sometimes instead of S, we write X. Okay, so basically this is the position time graph. All right, so we know that the slope of the position time graph represents the speed or the velocity of the body. So this problem here, you have two bodies, A and B. A and B, and their ST graph is given by the two lines OA and OB respectively. So we can see here that OA, the slope, it is making an angle. The line OA is making an angle 30 degree with the x-axis, whereas the line OB is making an angle 60 degree with the x-axis. So what is the question here? You have to find the ratio of the velocity of A to the velocity of B. That means VA by VB is equal to how much? That is what you need to find. Okay, and this is very simple. So what is VA? VA by VB? VA by VB is actually slope of A divided by the slope of B, right? And what is slope of A? This will be tan of which angle? 30 degree. 30 degree, and slope of B is tan 60 degree. Got it? Tan 30 is how much? Tan 30 is 1 by root 3, and tan 60 is root 3. So basically this is equal to 1 by 3 answer. That's the answer. Okay, so let us go to another problem. So in this problem here, you have to find the total distance covered, the displacement, average speed, and average velocity. So here this is the XT graph. Okay, the XT graph out here, right? And this graph is drawn here. The X is measured in meters, whereas the time is measured in seconds. Okay, so basically number one here, to find the total distance, let's call this total distance to be X. So basically it is a distance, it is going from this point to that point. The graph is going from this point to that point, is it not? So at this point the distance would be 0, means the value of X would be 0, right? At this point, what is the value of X? It's 40, right? So here it'll be 0 plus 40 plus, from here the graph goes back here. So from this point to this point, what will be the value of distance again? From 40 to 0, so again that will be 40. From here till here it is going 20, but we don't take minus 20. Why? Because this is distance, right? And distance has no direction. So basically the minus sign, it represents a direction. So we take plus 20, and again from here it goes back there, distance of how much? 20 plus 20. So if you add all this, you will get this to be 120 meter. That's the total distance. And then number two, let's find the displacement. Displacement, by definition, it is the final position minus initial position. Final position minus initial position. So where is the final position? Final position is D. So that means the value of X at D minus initial position is O, the value of X at O. Okay, this is D, mind you. Let me write this D properly. Okay, and here what is the value of X at D? At this point the value of X is 0, minus at this point the value of X is also 0. So basically the displacement is 0 meter. Number 3, average speed. The average speed by definition is total distance Total distance, let me write a full form, by total time. Okay, and what is the distance? Distance is 120 meter. And what time? From this point right to this point, what time? 6 seconds, right? 6 seconds. So here you have 20 meter per second. Number 4, the average velocity. Average velocity here is displacement by time interval. Time interval. And what is the displacement here? 0, right? Time interval is 6, so therefore the average velocity will be 0 meter per second. Okay, so let us go to the second, no, not the second, the third problem. Let me draw this diagram very quickly. Okay, so now you have this kind of a graph. This is the VT graph, the velocity time graph. Okay, and here you have to find the total distance. All right, and so number 1 here, total distance. Now we know that the total distance in the VT graph, this is equal to the area under the graph. What do we mean by that? Area under the graph. So we see the graph is going like this, OA, B, C, D. So when we say area under the graph, we mean the area of this shape. This is a polygon, O, A, B, C, D, O. Okay, so that means this is area of O, A, B, C, D, O. All right. So here we can divide this polygon into various shapes. So we have this triangle, OAG. Then we have this rectangle, AHEG. We have this triangle again, BCH, and this triangle, CDE. So basically it is the area of triangle OAG plus the rectangle AHEG plus this triangle BCH plus another triangle CDE. Okay, and we know the area of this triangle is half base into height. So half this triangle, the base is this length, and this length here is 2. Right, the height is this length AG, the height here is 2, plus this rectangle is length into breadth, that means this length here, GE, how do we know this length? It is 5 minus 2, so that means 3, into this length is 2, plus triangle BCH, this one. So again, this will be half base is BH is this length, which is equal to FE. So how do we know this length? It is 5 minus 4, which is 1, into height is this length. Okay, this length CH is, how do we get this length? 10 minus 2, that will be 8, plus this triangle, the big triangle, half base. Now the base here is this length. How do we get this length? 10 minus 5, which is 5, into height, 10 minus 0, which is 10. So you can do some cancellation out here. This and this will go. So you have here 2 plus 3 2s 6, plus you can cancel this and this. You will get here 4 plus 4, plus you can cancel this and this. You will get 5 out here. So that will be 25. Okay, so 5, 9, 15, 16, 17, 2 and 3, 37 meter. So that is the total distance. Let us now find the average speed. Okay, how do we find the average speed? Average speed here is total distance total distance by total time. Total time. And what was the total distance we obtained? 37, and the time is from 0 to 10. That means 10 seconds. Okay, so this will be 37 by 10. This is 37 meter, 10 seconds. So that will be 3.7 meter per second. The next one, let us find the acceleration. Acceleration here is the slope of the VT graph. Yes or no? The acceleration. We have to find the acceleration which is maximum. Okay. So we know that acceleration is equal to the slope of VT graph. Okay. So where is the slope maximum if we want to find the maximum acceleration? How do we know? You can just look from the graph itself. You will tell. You will be able to tell, isn't it? The acceleration is actually this angle. This angle here. Okay, so let's say that angle, and the angle acceleration here will be 0 because the angle here is 0. We have another angle here, phi, right? And another angle out here. So where is the slope maximum? So slope is maximum, meaning where is the angle maximum? So if you look here, you will see that this angle is largest. That is a maximum. Okay, so because of that, the slope of this line, oh sorry, what am I doing? Now let me just pause here a little bit. So you can see here that this angle phi is maximum. So the acceleration will be maximum along this line BC. Got it? So maximum acceleration means the slope. Sorry, let me use a white color for this. Slope of BC. And what is the slope of BC? That will be tan phi. Okay, and let us look at this diagram once again. Tan phi here is base by perpendicular. Sorry, perpendicular by base. Perpendicular by base. That means CH by BH. CH by BH. Okay, and what is CH here? CH here is the length. CH is 10 minus 2. That will be 8. And BH here is 5 minus 4. That will be 1. Okay, so this will be 8 by 1. So you get 8 meter per second square. That is the maximum acceleration. And we also find in which part of the graph the acceleration is maximum, and find its value. Okay, so that's what we just found. And we have to also find the retardation. Okay, the retardation, let me write here number 4. Retardation. Retardation basically is negative acceleration, right? And if you look at this diagram here, where is the acceleration negative? In this slope, CD. Okay, CD. So that means the retardation is equal to the slope CD. Got it? So this will be equal to slope of CD. And slope of CD is tan of which angle? Which angle? This angle. This angle here. Okay, we can take that angle, or we can take we can take that angle with a negative sign. Let's call this angle alpha. Okay, tan of alpha. So that'll be tan of alpha. Okay, again let me write with a white pen just to maintain the uniformity. All right, so tan of angle is what? Perpendicular by base. That means CE by ED. CE by ED, right? And because it is retardation, we have to put minus sign. Okay, so minus CE. CE here is the length CE. That will be 10 minus 0. That will be 10. and ed is 10 minus 5, that is 5. Okay, so this will be 10 divided by 5 minus 2 meter per second square. So that is our retardation. Got it? Okay, let us go to another problem. I think this will be problem, which problem number is this? Is it 3 or 4? This is 3, so this will be problem number 4. Let's see this one. Let's see this. Okay, so this will be problem number 4. Okay. So in this problem, a body starts from rest and moves with a uniform acceleration of 10 meter per second square for 5 seconds. During the next 10 seconds, it moves with uniform velocity. Find the total distance traveled by the body. Okay, so here, how do we do such a problem? All right, so it's quite easy for us to draw the graph, to use the graphical method. Okay. And if you look at this question, it says that it starts from rest. So that means the velocity of the body at time equals 0 is 0, right? So what kind of a graph are we going to draw out here? So since this problem talks about the velocity and time, so we have to draw the velocity time graph of the problem. Okay, so let us draw the velocity time graph first. Alright, so let's take the velocity along the y-axis and the time along the x-axis. So here this is the velocity, and the meter per acceleration is meter per second square, so this velocity will be in meter per second. Okay, time here is in second, so let's take t in seconds. All right, so this is the origin. Okay, it says that the body is starting from rest, so that means the graph should be starting from here. And what happened? And then it moves with uniform acceleration of 10 meter per second square for 5 seconds. So till 5 seconds here, till 5 seconds, it moves with an acceleration of 10 meter per second. So we don't know what is that final velocity attained by the body. So the body is starting from rest and it is going faster, faster, faster. The velocity increases. Okay, so let me just draw a graph like this. Okay, so let's say at 5 seconds it reaches that point. Let me just drop a perpendicular here from this point to that point. Okay, and then after that it moves during the next 10 seconds. It moves with uniform velocity. So now from here it goes uniformly during the next 10 seconds. So let's say another till here 10 seconds. So that means from here till here 10 seconds. So that means this point will be 15. Got it? So during that 10 seconds duration, it is going with uniform velocity. Okay, uniform velocity here. Okay, so basically this is the curve out here. Let me just draw one more vertical line. Okay, let me rub off this part. All right, so what do we do first? We have to find the velocity at this point. Okay, so what velocity it reaches, it attained as the body reaches this point. So we want to find the velocity here, and which formula do we use? Which formula? Let's use v is equal to velocity after 5 seconds. So velocity after 5 seconds, v is equal to u plus at. I think you remember this formula, right? And u here is the initial velocity. So because it is starting from rest, the value of u will be 0. Okay, and in this time of 5 seconds, it is accelerating with how much? With 10 meter per second square. So the value of a here will be 10. Okay, so what will be the value of the velocity? 50 meter per second. So this point out here corresponds to 50 and the unit is meter per second. Got it? Okay, so the question says that you have to find the total distance traveled by the body. So now, what is the total distance? Total distance is, because this is a VT graph, the total distance will be equal to the area of what? Of, let's name this as O, A, B, C, of O, A, B, C, O. That means of this polygon out here. Okay, quadrilateral basically. All right, so, and this quadrilateral is made up of this triangle and this rectangle. So that will be area of triangle. Let's call this point as D, of O, AD, plus the rectangle ABCD. Okay, and area of this triangle we know very well, that is half base into height. Base here is this length, and this length is 5 minus 0, which is 5, into height. Height is this length here is 50 minus 0, which is 50, plus this rectangle is length into breadth. So length here is how much? It is this length here, this side here will be 15 minus 5, that will be 10. Length into breadth, and this length here is 50 minus 0, that will be 50. So how much is this? You can cancel this in this, you'll get here 25 for 5, 5 so 25, 5 carries 2, 5 to 10, 11, 12, 125 plus 500. So this will be 5 to 625 meter. That is the answer. Okay, so these kind of problems you practice nicely, because they are quite conceptual and they are not so difficult also. All right, so they may come in the exam. Thank you.